In this video, we will learn the addition and subtraction formulas. So these couple formulas that we'll take a look at for sine, cosine, and tangent are among the most important identities formulas that we can know. We will use these to prove another few identities in the next few sections, and there are many useful applications of the addition and subtraction formulas. So we'll talk about the addition and subtraction formulas themselves first. We'll go through an example of how to use the addition and subtraction formulas. And then we'll talk about how to prove the cofunction identities, which we learned in the last video, using the addition and subtraction formulas. So first, the addition and subtraction formulas. The formulas for sine are sine of x plus y equals sine x cosine y plus cosine x sine y. And sine of x minus y is sine x cosine y minus cosine x sine y. The way to remember these is to notice that for addition, we have addition, and subtraction, we have subtraction. We always start with sine x cosine y, and we end with the opposite. The formulas for cosine are cosine x plus y equals cosine x cosine y minus sine x sine y, and cosine of x minus y equals cosine x cosine y plus sine x sine y. This one, I want you to notice that when we have an addition of two angles inside the cosine, we have subtraction. We also have a cosine of each of those angles, and then we're subtracting the sine of each of those angles. And cosine of x minus y equals cosine x cosine y. Again, we're starting with the cosine of each angle, and then we're adding the sine of each angle. The formulas for tangent. Tangent of x plus y equals tan x plus tan y over 1 minus tan x tan y. And for tan x minus y, that equals tan x minus tangent y over 1 plus tangent x tangent y. So again, similar idea here as cosine. When we have an addition of two angles, we have a subtraction in the bottom and an addition at the top. And when we have a subtraction of two angles, we have a subtraction in the top and an addition in the bottom. Now, I won't prove these for you, but you can prove them using the distance formula. I would encourage you to go into the textbook and take a look at that, or you can ask me and I'd be happy to write out the proof for you. Now, find the exact value of cosine pi over 12. Now, I don't know what a special right, quote, quote, triangle might look for pi over 12, but if we're clever, we can figure out that pi over 12 is the difference of two well-known angles. For example, I might propose that what if we say pi over 4 minus pi over 6? This equals 3 pi over 12 minus 2 pi over 12, and that equals pi over 12. So the first step is to figure out how we can write the given angle in terms of well-known angles like pi over 4 and pi over 6. Now we can say that, okay, well, cosine of pi over 12 just equals cosine of pi over 4 minus pi over 6. And now we can just use the subtraction formula for cosine, which is, remember, that's cosine x cosine y plus cosine x sine y. That is, we have cosine pi over 4 cosine pi over 6 plus sine pi over 4 sine pi over 6. So now, cosine pi over 4, we know that's root 2 over 2. Cosine pi over 6, we know that's root 3 over 2. Sine of pi over 4 is root 2 over 2. And sine of pi over 6 is 1/2. So now we just combine all of this. Root 2 times root 3 is root 6 over 4. Root 2 times 1 over 2 times 2 is root 2 over 4. So we have root 6 plus root 2 over 4. And of course, you could write that as a decimal if you wanted to, but this is good enough. So To review, what you do is you take a look at the angle that you have, and you try to write it in terms of angles that we already know. And then using those angles and the addition or subtraction formulas for sine, cosine, or tangent, then we can evaluate. Okay, another example. Prove that sine of pi over 2 minus x equals cosine. Okay, so this one is a sine subtraction formula. So first we should write that out. Now remember, for the subtraction formula for sine, we have sine x minus y, and that equals the sine of the first angle and the cosine of the second angle minus the cosine of the first angle and the sine of the second. So sine x cosine y minus cosine x sine y. So sine of pi over 2 minus x equals sine pi over 2 cosine x minus cosine pi over 2 sine x. And since sine pi over 2 is 1, we can write 1 times cosine x, and then cosine pi over 2, and then cosine of pi over 2, that's 0 times sine x. So altogether we have cosine x. So you can also follow a similar kind of proof for the cofunction identities for secant, cosecant, tangent, and cotangent, but this is just to get you thinking about all of these identities, or at least a few of them, in terms of the addition and subtraction formulas. In the next video, we'll look at how to evaluate expressions involving inverse trigonometric functions.